Hello and welcome to itnow, your all-in-one destination related to cloud computing, DevOps and SRE. Here in this channel, I will guide you on the journey through the world of IT innovation and technology. Today we are diving into the realm of DevOps, exploring why DevOps is important and what problem it solves. So whether you are new to DevOps or looking to deepen your understanding, you are in the right place. So let's not delay, let's start it. To understand why DevOps is important and what problem it solves, let's explore the traditional software development lifecycle or SDLC, which is a structured process used for developing software applications. The SDLC consists of several distinct phases, each with specific goals and activities. It starts with the requirement analysis phase, then moves to the design phase, then to the coding phase, which is known as development, then goes to testing, and after that it is deployed to the production known as deployment phase, and after that it goes to the maintenance phase. Now let's deep dive into each phases to understand their roles and challenges. The process begins with the requirement phase. In this phase, stakeholders such as business analysts, project managers, and end users gather and document the requirements of the softwares. This involves understanding what the software needs to do and the constraints it must be operating within. The outcome is detailed requirement specification that serve as a foundation for the subsequent phases. Following the requirement phase, we enter the design phase. Here system architects and designers create a blueprint for the software. This involves defining a system architecture, data models, user interfaces, and other components. The design phase aims to translate the requirements into a structured solution that can be implemented in the development phase. The result is a comprehensive design document that outlines how the software will be built. Then comes the development phase, where the actual coding takes place. Developer writes the software codes based on the design specifications. This phase involves using programming languages, frameworks, and tools to build software components. The goal is to produce a functional product that meets the design and requirement specifications. This phase can be iterative, with developers frequently testing and refining the code as they progress. Once the development phase is complete, the software enters into the testing phase. Tester and quality assurance teams validate the software against the requirements to ensure it functionally correct and free of defects. This involves various types of testing, including unit testing, integration testing, system testing, and user acceptance testing. The aim is to identify and fix any bugs or issues before the software is deployed. After testing is successfully completed, the software moves to the deployment phase. This is where the software is released to a live production environment and made available for end users. The deployment phase involves installing, configuring, and enabling the software for use. It may also involve data migration, user training, and documentation. The final phase of the SDLC is maintenance. During this phase, the software is monitored and maintained to ensure it continues to function as expected. This involves fixing bugs that were not discovered during testing, making improvements, and updating the software to accommodate the changing requirements. The maintenance phase ensures the longevity and reliability of the software over time. Maintenance being the last phase of the SDLC, it brings us back to the requirement phase, which comes with the bug fixing or the improvements which goes on in that cycle, making it a never-ending loop. Each of these phases is critical to the successful development and deployment of software, providing a systematic approach to ensure the final product meets the needs and expectations of the stakeholders. Now, as we've understood the traditional software development lifecycle, now let's deep dive a bit deeper to understand the challenges faced by the company during following the cycle. It starts with slow delivery times, lack of collaboration, inconsistent environments, manual processes, and limited feedback loops. Now let's understand these challenges a bit deeper. One of the major issues is slow delivery. Each phase of the SDLC is typically completed in isolation. For instance, once developer finishes coding, the project moves to the testing phase, which can cause considerable delays if the testing team is not immediately available or if the testing process is extensive. This sequential hands-off between phases can often lead to bottleneck or prolonged delivery times. Another critical challenge is lack of collaboration between different teams. As the process needs a lot of collaboration, but in traditional software development, testing, and operational teams usually work in silos. This separation can lead to miscommunication and misunderstandings. For example, developers may not be fully aware of the operational constraints, leading to code that works in development but fails in production. Now let's dive into the next challenge, and that is inconsistent environments. This challenge leads to an infamous problem that I think you must have heard at some point, that is, it works on my machine. For those who don't know, let me explain. Developers often test their codes in the environment that is different from the production environment. So when the code is tested in the dev, it works fine. But when deployed in the production, due to configuration difference, it fails. This brings a lot of miscommunication and chaos between the dev, QA and operation teams, causing delay in the application delivery time. The next challenge is manual processes. Manual processes, especially in testing and deployment, are prone to errors and can cause highly time-consuming. For example, manually deploying a software update involves several steps that can easily lead to mistakes, causing downtime and failures in the production environment. These manual steps slow down the release cycle and introduce high-risk human errors. Finally, limited feedback. Limited feedback loops in the traditional SDLC leads to delay in identifying and resolving issues. Bugs or performance issues discovered in the production might take a long time to trace back and fix, as feedback from the end users or monitoring systems is often slow to reach to the development team. This delay in feedback means the problem persists longer and can impact user satisfaction and product quality. Now, as you have understood properly what are the issues that comes with the traditional software development lifecycle, now it will be easier for us to understand why DevOps is important. With the issues mentioned above are being a headache for a company, it causes a lot of waste of money and time. All of these issues can be encountered with the implementation of DevOps. With the DevOps implementation, it improves the following aspects, that is, faster updates, better experience, fewer failures, higher quality, faster product delivery, cost savings, stability, shorter dev cycle, lowers risk, efficiency improvement, reduced time to recover, and higher reliability. In conclusion, DevOps addresses the key challenges of the traditional software development lifecycle by promoting faster delivery, improved collaboration, and consistent environments through automation and continuous feedback. Organizations adopting DevOps can achieve significant improvements in software delivery speed, quality, and operational efficiency. By forecasting a culture of collaboration and leveraging automation, DevOps enables teams to respond quickly to changing requirements, reduce errors, and enhance overall productivity. As a result, companies can better meet customer demands, stay competitive in the market, and ensure the reliability and scalability of their software products. Embracing DevOps is not just a technical shift, but a cultural transformation that drives continuous improvement and innovation. In the next video, we will deep dive into all the solutions that comes with the DevOps implementation one by one, understanding the DevOps principles, and what are the DevOps tools to achieve the solutions. In the end, we will examine the case studies showcasing how top companies have benefited from adopting DevOps practices. So stay tuned for the next video. If you found this video informative, please like, share and subscribe to our channel. Your support helps us to create more valuable content for you. So thank you so much for watching and happy learning.